Good morning, everyone, and welcome to today's webinar from the Offshore Renewable Energy Catapult. I'm Audrey Bowie. I'm a Senior Project Manager at Catapult, and I've been working with the Rovco team on the development and testing of their SubSLAM system over the past 18 months. Integrating robotics and autonomous systems into offshore wind operations is one of Catapult's strategic priorities for the offshore renewables industry here in the UK. And it's our mission to support innovative companies like Rovco in developing solutions that are going to lead the industry's global supply chain and in the process create some really highly skilled jobs for the future. Rovco first came to Catapult's attention back in 2017. At the time, they were a really small team of 3 people with a novel concept for robotic subsea inspection system. And since then, we've collaborated on 2 Innovate UK projects to develop and test the system. Rovco's really firmly established as one of our game changer SMEs, and they've attracted the attention of Scottish Power after winning the Offshore Wind Innovation competition back in 2018. So today we're going to hear a bit about the Rovco technology, and from our panelists, we'll do some introductions now before we dive into the technical and logistical practicalities of this project. So if we start off with Ben, Ben from Rovco is a Senior Computer Vision Engineer. Ben, do you want to give yourself a quick introduction?
Sure, thanks Audrey. So yeah, as Audrey mentioned, I'm a Senior Computer Vision Engineer at Rovco, and I'm the technical lead for the Innovate UK project that we'll be talking about today. I joined Rovco in 2018 and have been involved in both of the Innovate UK projects that we've collaborated with the Catapult on. And hopefully I'll be able to give some interesting technical details today on the work that we're doing.
Brilliant, thanks Ben. And next we'll go to Mike. So Mike's the Technology Business Development Manager at Rovco. You want to introduce yourself, Mike?
Thanks, Audrey. Yes, I'm Mike Gall, obviously Technology BDM. I am actually based in although I'm from home today, but I'm officially based in our newly established Edinburgh office. And my main remit, I've recently started studying in February, my main remit is the commercialization actually of our technology to other customers. So Rovco remains a service company, but actually also thanks to the support of Audrey Catapult, we now have the technology that is such a mature stage that can be also commercialized externally. And that's going to be our main remit, my main remit, sorry.
Brilliant, thanks Mike. And last but not least, we've got Andrew Kirkland from Scottish Power Renewables. Andrew, do you want to introduce yourself?
Yeah, sure. Okay. Thanks, guys. So yes, I work for Scottish Power Renewables. I have done for about 5 years. I'm a Senior Geophysical Engineer working on ground engineering across not just Scottish Power projects, but all of Iberdrola's offshore projects. So in the US, in the Baltic, and all of the East Anglia works from EA1 to the EA Help works. And as Audrey mentioned at the start, we've had involvement in this through the innovation competition and have been sort of following, I suppose, Rovco since that competition and the progress through that.
Brilliant, thanks Andrew. Okay, so before we dive into the discussion, I just want to let all of you viewers know that you're welcome to put questions into the Q&A, and we will pick these up during and after the discussion. We'll try and answer as many as we can, but obviously we're limited on time, so we'll do our best. And just to also let you know, this webinar is being recorded and will be available on the Catapult YouTube channel after the event. Okay, so I think the big question to start off with is for Andrew. Can you tell us a bit more about why Scottish Power Renewables cares about this project and what Rovco's doing?
Yeah, sure. So I suppose right from the outset, any company in offshore wind is always looking to see advancements in technology and sort of that huge stepwise change in where progress is going for not just surveys, but also for automation and generally just technology in general. So me specifically, I've got an interest in the side of basically the inspection side of things that Rovco can do. So typically we would do things like scour with conventional equipment like bathymetry and the like, or various other forms, side scan, sonar. These kind of types of equipment are still used today, and you can get various forms of resolution with that. But Rovco, what we've discovered, are really kind of getting to the point where they're taking that next step and providing deliverables and sort of data that is more detailed and certainly appears to be of that next sort of level of accuracy. So that I think kind of touches on why we're interested in this concept.
Yeah, I think it's a complete step change, isn't it, from the way that we do things now. So it's really exciting to see. And Ben, maybe you can give us a bit of an overview of how this project addresses that and what the technical deliverables are of the project.
Yeah, sure. So I like to think of it in sort of three categories. The first of which is better data. So as Andrew mentioned, you have bathymetry data, you have video data from existing technologies. They are limited in terms of their resolution. Like a lot of ROV camera tooling is surprisingly low resolution actually when you look at it. And then sonar, yeah, it's got issues with the resolution you can achieve of the data. And also, if you want to build a consistent 3D model with sonar, you're looking at adding on an INS system, something like that, to keep track of position. So the way that we address that with SubSLAM is by using high resolution camera sensors, using the latest digital camera technology, and doing simultaneous localization and mapping, or SLAM, which is capable of tracking the ROV position and building a 3D model of the environment in real time. So yeah, better data is one of the cornerstones of the project, and anyone that's got a smartphone can see how quickly the digital camera technology is moving, and we really want to stay on top of that and be using the best sensors available in our camera systems. Besides being able to get better data, we want to be able to get it faster. So that means both in terms of collecting it faster and delivering it faster. And I think hopefully we'll get a chance to go into this in more detail, but that means being able to deliver data as it's being collected directly to the desk of any interested engineer like Andrew, or being able to collect data using smaller vessels, smaller ROVs, and flying it quickly around your asset. And then the final sort of thrust of the project, I think, is better use of the data. So people want to be able to use data to compare the condition of their assets from now and in the past. So we want to give them accurate 3D data that can be used for these quantitative comparisons. So where previously people might have been putting divers in the water to measure things, we can get you those accurate scale measurements. And not only that, but also the high quality video data gives a really good opportunity to start making use of all of the advances in machine learning that are happening at the moment. Again, this is such a rapidly developing field that it's important to have a strong R&D focus in your business to keep on top of the latest developments and deploy them to your products. So deploying machine learning techniques to save hundreds of hours of video footage review time and get really repeatable results is one of the other key aspects of this project.
Yeah, and I think the whole idea of changing the types of jobs that are in the industry, so rather than divers, you've got really skilled people on shore working much more effectively. You don't have the risk of going offshore, which are managed just now, of course, but you know, the aim is for everyone to make it as safe as possible. So it really enables us to do that, and actually with really good quality of information. So I just want to touch on briefly the funding for this project. So this and the previous project, which Ori Catapult have done with Rovco, and obviously Scottish Power are now involved in this one, are both being funded by Innovate UK through a grant, which really supports the project to being able to actually spend the time and effort on research leading these things without, in the first instance, having to be too concerned about how are we making money out of this. Obviously, you need to invest to be able to develop the technology. So I guess it's also useful to know for others who are looking to develop technologies that this funding support is available from Innovate UK, and it's been a massive support to this specific project.
Yeah, Innovate UK has been really key to Rovco's R&D success. I mean, one of the reasons that I was hired was because we were awarded this project, and that could guarantee my salary for the next year and a half or whatever it was back in 2018. But yeah, it's been really helpful for Rovco to be able to have such a sizable R&D team, given the size of the company that we are. Innovate UK has supported that heavily, and also the sort of backing of Innovate UK has helped us attract private investment as well.
Okay, so I think now that we've done some introductions, hopefully everyone has a good idea of what's involved in the project and the setup that we have. Ben, it'd be great to hear from you a bit more technical information about the technology and see some of the outputs of it. So if you have a presentation to share.
Yeah, so like our technology is very visual, and I think it's really best explained by sharing some slides. I promise not that this won't be just like me talking non-stop for half an hour.
I'll stop you if it becomes that.
So hopefully people will be able to see a presentation any second now.
And can I just remind everyone, if you've got questions, just pop them in the Q&A box and we'll come back to them once Ben's finished going through his visual presentation.
So I wanted to start off by sort of explaining where we are now and what our current capabilities are, and then talk a bit about what the key outputs of this project have been. So yeah, Rovco developed the SubSLAM intelligent data collection system as part of phase 1 of AEV3D, and then made a commercial offering from that, which is currently on the market and has this, we've got 4K cameras, we've got AI at the edge with a powerful system on chip in the enclosures, really accurate relative positioning from the SLAM algorithms, and live 3D models, which we can prove the accuracy of because of the testing facilities that we've been able to make use of thanks to ORE Catapult. Yeah, it works purely from the stereo camera system. There's no scale bars or additional sensors needed to produce true scale 3D output. And a lot of this work is down to, is motivated by reducing vessel time. So the live 3D data delivery stuff allows you to make decisions as the survey is happening and avoid rework. You don't have to go out and recapture something because you've missed it. Photogrammetry systems have suffered from that in the past because you don't have your live results. So who knows whether you've actually captured everything that you need. Also, it's a system that can be deployed on small observation class ROVs. All of the trials we've been doing so far have been using Mojave and Falcon observation ROVs, Obviously, it can fit on larger things as well, but it gives you the opportunity to use smaller vessels and save CO2 emissions that way. So next slide is just a short video of the technology running live. So this is from a local testing site, one that we've thankfully still been able to use even during the COVID-19 pandemic. So this is an example of the camera system building a 3D model as the ROV is surveying it. This is an old crushing works from a now flooded quarry. And this gives you an idea of the sort of scale of model that we're happily able to build and the sort of coverage that you can get even with a fairly cursory overview with the ROV. In a moment, you might see loop closures happening and the model adjusting as this occurs. So this is how we guarantee the consistency of our data, and it's how we can prove the accuracy. One of the things that you're always dealing with, I mean, in any real world situation, you have sensor noise, but because of the optimization that underpins SLAM as an algorithm, you have an idea of how much your measurements are agreeing from one moment to the next, and that gives you a way of quantifying the accuracy of your data. So this is where we are now, and the project has been about pushing this offering to the next level. I mentioned earlier that one of the things we're trying to do is save vessel time. Stereo camera systems have traditionally required calibration, and doing an in-water calibration adds sort of 5 or 10 minutes to your dive time. So we're looking at eliminating that. So this is an example of a comparison of 2 point clouds. One was built using a traditional in-water calibration, the other was not. The scale here is all the blue data that you can see there is less than 2 millimeters different. And you can see there's some stuff where it's green and verging into red. That's actually mostly down to the models not including all of the same points. But obviously this is work that we really need to prove the efficacy and accuracy of time and again before it goes out into the world. So this is one of the things that we are doing to reduce mission time and increase the availability of the data. Another avenue we're looking at is image enhancement. Any imaging system is going to be limited if you can't see anything, but we have used some, we're using a combination of techniques actually, from straightforward image processing to improve contrast, to using some of the next generation camera sensors. It's been known for some time that you can reduce the effects of backscatter, which causes this sort of glow that you see in underwater imagery that increases with depth. People have been using circular polarization to address this. Unfortunately, with polarized cameras, or sorry, with polarized filters, you're cutting down on the amount of light that's getting into your camera. And that's not something that you want to do when you're relying on artificial lighting at 300 meters or 1,000 meters below the surface. But now you can actually get cameras which have polarization filters built into the sensors. And this is like running a camera with multiple different polarization filters at multiple different angles, all at the same time. And you can use that data to improve the visibility and the contrast available in your subsea imagery. And then that in turn leads into improvements in your SLAM performance. One of the other avenues that we're looking at is making the system really robust to rapid motion. Again, this allows you to collect data more quickly and keep collecting data even if there's, I don't know, the ROV is suddenly tugged around by its tether, or if you're working in very strong currents. There's a video here that shows, again, some of the work that we've been doing to improve our algorithms to allow really rapid motions to be tracked. And this is, you know, turning your ROV thrusters up to 11 and spinning it from side to side, and it's maintaining tracking and building a model the whole time. Hopefully you'll see the data, the view of the 3D model being manipulated in a moment to show that even when it's undergoing these really rapid motions, it's still producing an accurate model that's reflecting this 90-degree corner accurately. As the model, as the ROV moves through environment, it can deal with varied lighting. So you sort of just switching the ROV lights on and off, and it maintains tracking throughout that. And the sort of resolution that you can achieve with this data is quite impressive. As the ROV tracks up one of the sidewalls in a moment, you'll see some of the concrete rebar, which is poking out of this old structure, and it's modeled accurately, even using these new algorithmic advancements, which allow for the really robust tracking in high dynamic environments. It's just coming into view there, and you can see on the 3D model that that's accurately picked up. So this is exactly the sort of accuracy to be able to identify the scour on your monopile, or the points at which there's corrosion, or your cables in free span. These are the sorts of accuracies that our intelligent data collection system can deliver. I talked earlier about not only improving the speed of data collection, but also data delivery. So live streaming of 3D data is one of the things that we've been working hard on in this project. I always think of it in terms of the difference between data and information. So with a 4K camera, you get huge amounts of data and also a lot of information, but there is a big gap between that. Typically you aren't looking at every pixel of every frame of a video that's several hours long. And in fact, by transmitting 3D data rather than video data, there's a huge cut down in the amount of raw data that needs to be transferred, but you still retain all the information content. You still retain all the measurements that you get. So our streaming service is something that can cut down the data but retain the information, and that's what's key for making decisions. There's a short video just showing a demo of this. This is actually, I was on the boat when this data was being taken, and this is one of our engineers looking at it being streamed back to the office. You can see there that you're just getting infrequent updates on the video stream, but the live data is coming in as it is being built. So roughly once a second, or maybe a bit more frequently, you get this data stream coming through. A lot of work has been done on image compression and video compression. It's used everywhere. I mean, Zoom is making heavy use of it now in this webinar. Compressing 3D data is actually a slightly less well-studied topic, but it's something that we've been working on in AEV 3D. And it's one of the things that's enabled us to get this live 3D data streaming working with high fidelity, but on really low bandwidth links. So in the reconstruction that you can see at the moment, the bandwidth peaked at about 60 kilobits a second. So this is the sort of stuff that's easily achievable with VSAT links and the sort of low bandwidth links that you can see in marine environments. The live 3D data streaming really hooks up nicely with our intelligent data platform. And that's somewhere where you can combine a whole bunch of different data. So you might have SubSLAM photogrammetry data, SubSLAM SLAM data, or SubSLAM photogrammetry data. You might have bathymetry from traditional sonar solutions. You might have above air, in-air photogrammetry from drones. So there's an example here of a data set from a monopile that has combined all of those modes of data collection into a consistent data representation, and developing the platform that has all these, that can deal with this multimodal data is one of the elements of the project, and something that our web team lead has really achieved an impressive amount on over the past 18 months. The other thing that we are really concerned with in Rovco is making sure that the data that we're providing is accurate. Basically you can send all the data you want and you can send it wherever you want. If you can't prove that it's accurate, what good is it to us? So this is where the Catapult have really come in for us. They have got these facilities that have allowed us to prove the accuracy of our system. So here we've compared the results from Leica P40 laser scanner, which is a terrestrial laser scanner, which is sort of an industry standard, to results from SubSLAM. This is only possible because of the testing facilities that we've got access to thanks to this project. Unfortunately, the Leica P40 doesn't like being submerged in water. So the access to dry docks is really useful. It means that we can choose representative subsea assets, put them in a dry dock, scan them using this laser scanner, flood the dock, and then go and build a model using our SubSLAM system. You can see in the next slide some photos of the facility. This is the dock on the far left. We've actually got in the background there a mock monopile that we built specifically for this project, which we're using for testing and validation of the technology. In addition to testing in the docks, we've got to prove ourselves in more realistic environments. Now, on the one hand, we're doing that all the time with our commercial work, but when we're wanting to test new developments, we need to do that in representative real-world environments as well. And that's where we've made use of the meteorological mast, which is about 5 kilometers offshore off the coast of Blyth. And that's what we've got an image of on the right-hand side there. So part of the project has involved trials, modeling the tripod base of this, the meteorological mast here. And actually we were due to be doing that again, well, about 4 weeks ago, but sadly the real life impinged and the COVID-19 pandemic has prevented us from doing that. We're rescheduling those trials for later in the year, and we're really excited to share the results with everyone. In addition to the work just improving the data collection and the sort of data that we can build, we've got a lot of work going on to analyze the data and produce metrics from it that people can use to keep track of their asset integrity. And a lot of that work is based on machine learning. There's an example here of a machine learning pipeline analysis, which is picking up things like field joints and other anomalies. This is part of the web platform that we've developed. And it's the sort of thing that can work with SubSLAM data or, in fact, any other video data. It's not exclusive to the SubSLAM camera system. what the SubSLAM camera system allows us to do is push the AI to the edge and enable us to do this machine learning live whilst the data is being collected. Just a quick example here of the sort of analysis that can come out of the machine learning work we've got is you can get summaries over your data delivered in the web browser to whoever you want, but only those people you want. One of the reasons that we built this system from the ground up is we know how important data security and data integrity are. So basically the future vision that Rovco have is summarized quite nicely in this infographic. I think that you've got robotic platforms operating collaboratively, sharing data to the people that need it with minimal supervision, and allowing the ROV operators to collect data in any conditions. And yeah, I think that's probably enough of me talking. So have we got any questions from the audience, or just from yourselves actually?
Yeah, Ben, we've got a few questions actually that have come in while you've been talking. So the first one is from Pete White about what software do you use for the visualization of the 3D model?
So we've got a few options really. Our data platform will visualize 3D data just in a web browser, so you don't need any specialized software for that. But also we can provide the data in formats that are usable in a whole host of software. So I sometimes use Cloud Compare or MeshLab. I know that other people have their own favorite software, but yeah, it's available in various different formats.
Brilliant, thank you. And there's a couple of other questions, but we'll come back to those at the end if we have time. So I think there's, I've seen it loads of times, but I actually love seeing those videos about you can really understand what the technology is doing. And I think the picture of the future, I mean, it's really thinking big and really changing completely the way that we work. So Andrew, can you kind of give us a bit more on what benefit you see this having to the likes of Scottish Power Renewables with this big future vision?
Yes, sure. Sorry, I was on mute while my son was being put down for a sleep. Yeah, so I kind of touched on it at the start, but basically we want to see the high quality data that you probably can't get, well, we know you can't get with the conventional forms of survey acquisition. But on top of that, I think examples like asset integrity and looking at the O&M side of things, that's really where there's a huge advantages to using this kind of equipment, and not just for asset integrity, but also for things like cable feasibility assessments or cable burial. There's a lot there that you could do with getting very high accurate data, and therefore a lot more confidence in the results, which I think you would have less confidence in with your standard bathymetry and side scan, whether that's just vessel mounted or even on an ROV. So yeah, I suppose it's through those kind of examples that I see there being an advantage using this kind of technology.
Absolutely. And Ben, do you have anything, or Mike, do you have anything else you want to add to that?
That sums it up quite nicely. So.
Yeah, I think it really does. Can you, Ben, can you just explain kind of, and I know you've touched on it quite a lot already, but how the project helps some of the main challenges and what those challenges are in terms of actually making all of these technologies a reality, less from a technical point of view, but more from a logistical point of view?
Yeah, sure. I mean, there's been a lot of R&D effort that's gone into this project. So the project has enabled us to make a lot of new hires, expand our team. And also, yeah, it's given us access to these testing facilities that otherwise we wouldn't be able to use. It's really helpful to have the involvement of someone like Andrew at SPR, because it's all well and good to go and develop new technology. You need to know that that technology is going to be useful for the client. So understanding what their needs are is key to that as well.
And I think just on that, we've talked about this before, but one of the things we're both in discussion about at the moment is just for those that are on this conference, is understanding the differences between your standard survey techniques and this innovative 3D photogrammetry or machine learning, and knowing that you're not going to get an apples to apples comparison, but understanding what the improvements are with this different type of technology.
Mm-hmm.
Yeah, and I think there's less interesting things to look at in terms of the piece of work that's in the project. But one of the things that ORE Catapult that we're doing is to try and figure out a way that somebody like Andrew could say, no, it's not apples to apples, but how do we compare the traditional survey methods with these cutting edge technologies, and trying to do that from an objective point of view, rather than, you know, obviously in a kind of internal Rovco point of view, where obviously you want to make the specifications so that yours comes out on top, but we're doing that from an objective point of view. So hopefully that will be helpful to industry once we finalize that. Ben, were you going to say something there? Sorry, I interrupted you.
No, that's fine. Yeah, it's something that we think about a lot, actually. So there are other technologies which maybe are able to be more easily compared to the SLAM technology and photogrammetry stuff. But what we really need to know is how it's going to impact operators, essentially, and the clients. And I think that's a really important bit of work that's come out of the Catapult, is these criteria that describe what's useful. Sure, we could make something, you know, that can pick up some tiny difference on the micron scale, but no one's going to, if no one cares about that, then we don't want to spend the effort doing it. So yeah, I think it is really important to understand what those goals are in terms of the business, essentially. Like, how is this going to improve? How is this going to decrease the levelized cost of energy?
Yeah, so watch this space for the answer to that. Okay, and I think Andrew, do you have any questions? You're muted.
This is constantly a live bit of background noise going on here, so I've got to be quite canny with my mic. So I sort of touched on there what we're interested in, which is this being able to compare the two different type of techniques, conventional with the new stuff we have going on. One of the things I have wondered for a while is if Rovco are interested in expanding away from just the very specific likes of asset integrity or cable burial and cable inspections to wider site surveys where you could do very high resolution bathymetry, or if that's a completely different kind of, I guess, kettle of fish.
Yeah, I mean, it's definitely something that we're interested in doing. There are always trade-offs to be made, essentially. Basically, there is a trade-off between the resolution of data that you can get and the swath that you can cover. So the system that we've got at the moment is something that typically works maybe up to 5 meters, 10 at a push, like working range. So it's not something that you're going to do a worldwide bathymetry survey with. But it's certainly something that can be used over an area, like inside a wind farm or something like that. And we're also always looking to integrate more sensors and more data into the system. The SLAM provides a really nice way of anchoring everything, essentially, because of the positioning that you get out of it. You get real-time pose estimates. So that could be used to fuse in data from other sensors that might achieve that wider swath, or any other sort of sensing modality that you want.
Yeah, okay. And then just one other I had, which is sort of related to that, is have you had any interest in scoping for boulder detection on the seabed surface? So not necessarily for a full site, but for export cables or inter-array cables, because quite often people want to have an understanding of the expectation of the number of boulders they'll have prior to actually going and doing construction. And typically you find that side scan sonar is quite often orders of magnitude out with the number of boulders that are picked.
Yeah, I think that's the sort of thing that would be particularly well suited to the machine learning things that we're developing. So I've talked a lot about what we've been doing in this project during this webinar. We actually have another Innovate UK project running at the same time. So that's focusing more on the development of autonomous vehicles and using the technology from the SubSLAM camera as sort of the core of the autonomous navigation stack. But along with that, you could have an autonomous vehicle that would fly a sort of a lawnmower type pattern that would give you a really accurate survey of your planned export cable route. And then you could have the machine learning algorithms running on the video data, giving you really accurate boulder detection.
Yeah, okay. Yeah, sounds good.
Thank you very much, Ben and Andrew, for those. I'm keen to move on to the Q&A now. We've got about another 10 minutes to get through some of the questions. We've got loads coming in now, so I'm going to just try and pick some of the key ones, and if we can keep our answers short and sharp, we'll get through a few more. And any questions that we don't get to answer, we can contact the people who question, ask them afterwards. Okay, so question from John Best. Do you see this ability of highly accurate asset auditing impacting the future of new owners? So less technical, for example, pension financing companies having greater confidence in purchasing parts of wind farms as owner of their portfolios whilst reducing overall cost. Note, would you buy a house without a survey? I think that one is for Mike.
Yeah, I can take it. Yeah, absolutely. It's exactly the good thing of having an accurate baseline model of your wind farm, and also with the type of work that we do on wind farms, the fact that we can also collect historical data when we go and do again these type of surveys. So absolutely, we can provide the baseline and all the information on how the wind farm potentially has aged through time. So that's definitely good data sets that can be used as a kind of like MOT test of your wind farm. So absolutely, definitely potential for this.
Great. Thank you, Mike. Okay, next question. What level of measurement accuracy can you achieve on assets like mooring chains, mooring chain links on an FPSO, which are often a moving target?
Yeah, it's actually a good question. We are actually going to do a job. We've done this type of jobs, and we're going to mobilize again on a job soon that it's got this scope of work. So obviously movement needs to be checked, but the fact that we can collect data faster, if you can, manage that the particular chain to not be moving as much, we can actually get quite accurate data set that stays in line with the capabilities of the system. So you can get around the millimeter accuracy with good post-processing, absolutely.
Yeah, one of the advantages of the positioning that the SLAM does is you get really accurate relative positioning. So if the chain is moving, but the ROV is, the chain can be moving without affecting the accuracy of the model data, is essentially what I'm getting at.
Brilliant. Okay, thanks, Mike and Ben. And then we've got a couple of questions which probably link together quite nicely. So from Anthony, how do you see the SubSLAM system integrating with autonomous vessels, ASVs or AUVs? And also, will the future platform allow integration from aerial drones to allow whole asset recording?
Yeah, I mean, we absolutely see the SubSLAM system being part of an autonomous solution. I mentioned already that we've got another Innovate UK project working on using it as part of a AUV. ASVs are another really important part of the puzzle. So in terms of the live data delivery, an ASV is going to always be able to have a much better data bandwidth than something that's underwater. And it can also act as the platform for a drone, for example, to allow this, this topside underwater full survey to occur from an autonomous platform. And yeah, the web platform that we're developing is absolutely capable of merging these different data modalities.
Yeah, if I can add probably to what Ben's saying. So we have started as Rovco from the subsea and from the subsea environment, but we're not stopping there. So there's definitely vision from getting out of the water, going into the air and moving on to the ground. So it's going to touch all the elements. So yeah, we've probably done the hard bit first, which is the subsea environment. And then we hope or imagine that doing the rest should be relatively easier than doing it in the harsh environment that's the subsea.
Sounds like we're evolving like humans did there, starting in the ocean, moving onto land. Humans will be flying before you know it.
Then we'll take over the world. Okay, great. So I think we've probably got time for a couple more questions. Probably one for you, Ben. If the customer needs absolute world coordinates, how do you know where in the world the data is? Can you fuse with INS or USBL or LBL?
Yeah, so we can fuse with any source of absolute positioning. We can even do that actually without a live source of absolute positioning. If you have a datum in your offshore asset, then we can get all our positioning relative to that. But yeah, the intelligent data platform is essentially a GIS system. It supports any sort of coordinate frame that you can imagine. Before I started working in subsea, I actually developed INS systems for terrestrial use. And so my experience with GPS and coordinate frames is slightly more than I think I have ever wanted to know about these things.
Brilliant. Okay, thank you. And then, so a couple of quick questions which I'll answer. So somebody asked, is it possible to get the presentation? So we'll be uploading the video of this recording to the webinar, or of the webinar to the Catapult YouTube channel. So you can search for Offshore Renewable Energy Catapult and you'll be able to find the video with the presentation in it there. And then we had another question on the field trials in Blyth and the dry docks. Was this accessed through ORE Catapult? So the answer to that is a quick one, yes. So we have 3 dry docks, which we can fill and empty as required, and the met mass also belongs to us, which is just offshore. So through the partnership, through this project, we're able to provide access to Rovco to use those facilities, amongst many other things that we do. Okay, so I know we haven't been able to answer all of the questions. I'll give Mike, Ben, Andrew one last opportunity to answer any questions that you've seen come in that you have a burning desire to answer.
I think fortunately for me, they're all fired directly at Rovco.
You escaped lightly, Andrew.
Sorry, I've not had a chance to look through the questions yet, so I'm just having a look now.
That's okay. So for any questions that aren't answered, we'll contact you directly. For those who answered the questions, we have your login details to the webinar that we can send you them. Anything else from you guys?
Okay, so I've seen a question about data holidays. I think that's probably referring to like sort of patches that weren't picked up in the 3D model that I was showing earlier. So the, sorry, I'm just trying to find the actual text of the question.
So
there seem to be, oh yeah, okay. There seem to be data holidays in the models. Is that something that can be solved by increasing the number of passes, or are there sections that can't be resolved? So the short answer is yes, it is something that can be solved by increasing the number of passes. In fact, often it's not even necessary to do multiple passes. The videos that I've shown today are mostly from tests that we've been doing for evaluating new elements of the system that we've been developing, and the focus of the pilot flying the system has not been on getting a high coverage model, but it's perfectly possible to fill in those gaps.
Good to know. Okay, great. So I think we will wrap up there. Like I said, any questions that weren't answered, we've got quite a lot of questions. So any questions that weren't answered, we'll get back to you. Thank you very much for joining us today. Thank you to the panelists, Ben, Mike, and Andrew. And you can find the webinar on our YouTube channel with links to the presentation. So just search for Offshore Renewable Energy Catapult. Any additional questions, you can send them to us at info@ore.catapult.org.uk. And you can find out more about our projects on the ORE Catapult website. Thank you very much, everyone. Hope you all have a good Friday and weekend. Take care.